So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own Mascot at this side, and we are here at the lecture number 4 of the linked list series. In this video we are going to discuss, firstly we will look at a new type of linked list which is known as doubly linked list. Now after that we will be looking at the insertion in the doubly linked list and then in the deletion in the doubly linked list, right? There should be not any problem. I guess the three topics are very easy. Just stay with me, right? Okay. So up until now, we have only discussed about the singly linked list, or I say that only linked list, right? Our linked list looks something like this up till now: 6 connected with 4, connected with 3, connected with 2, right? Connected with, like, this was the pointer. That this is was my data. This was my next pointer, and this whole thing was my node, right? I hope you remember all of that. Now moving forward, what was the primary implementation of the primary cause of creating a linked list? We wanted to make an array of indefinite size. That is, we can either change the array, that is, we can either increase the array or decrease the size of the array, right? And we wanted to maintain the array like properties. Right? So in an array, suppose this linked list is actually an array 6 4 3 2. What are the benefits of an array upon a linked list? Up until now you must have realized what are the benefits. So one of the benefits is that in linked list I have to traverse from here, then here, then here, then here, right? So it takes a lot of operations. But in array I can access them by indexes: 0 1 2 3. I can access any element by indexes. So what is my first advantage? Indexes, right? Second advantage is, as in the linked list I can go, like, if I want to find what is occurring after 6, I can say 4 is occurring after 6 because there is a next pointer which leads to me to this node, right? Similarly, I can say for 4, what is the next operation? It is 3. For 3, what is the next operation? It is 2. For 3, it is, what is the next operation? It is 2. So you can see that I'm able to see that 6 has 4, 4 has 3, 3 has 2. I'm able to establish that connection, right? I'm able to establish the left to right connection is there. Left to right connection is there. But in the case of linked list, what I'm lacking is I don't have a previous connection. That is, if I am given a reference to 2, I cannot find if 3 was there, right? What is the back of the 3? What is the back of the 2? It is 3. I cannot answer that in the linked list, but in the case of an array, I can answer that. I can simply say index minus minus and I will get that element, right? So right to left is an added advantage in the case of array, right? So I cannot remove this disadvantage, but I can remove this disadvantage in the linked list. How? So my approach would be, I already have my next pointer. I will make another pointer, something sort of this, which will keep a reference to previous also, That is, in the first half, the linked list was looking something like this: 6. This node is connecting to 4. This node is connecting to 3. This node is connecting to 2. This was my simply linked list. Now I am saying to make a modification, something like this. I am saying keep the linked list same, just add 2 pointers, that is 6 here, 4 here, 3 here, 2 here, right? These are my nodes now. Now this will be data node, as it is always predictable. This will be my next node and this will be my previous node. Now next node will point to the next value, that is something like this. These are my next connections, and similar to the next connection I will have my previous connection. So previous will point towards the previous node. Now the base case is the head. This is my head, right? This is my head. I hope you all remember that this is my head. So the head's previous is obviously null because I don't have anything before head. And similarly, the next pointer of 2 is actually pointing to null, right? So in the singly linked list case, I will actually connect it to one null, but in the case of doubly linked list, I have 2 nulls on my side. One is at the head side, one is at the tail side. This is my tail, right? One is at the tail side. Now this type of linked list is known as doubly linked list. And now we want to move towards the implementation. Just as we move towards the implementation of the singly linked list, we showed that how do we implement the singly linked list in the VS Code. Now we will see the how to implement the doubly linked list in the VS Code, right? So as in the case of singly linked list, I made a struct node, right? I made a struct node, something look like this. So struct node. What did I do? I created a data type for keeping the data, the value I want to store. After that, I made a node star value, right, which maintained my next. I will not repeat, I will not get into depth of why star. I have already explained in the lecture, so I will attach the link to the description, so please just watch it. Node star next, right? And now, because in the single linked list I was already keeping my next pointer as my reference, I also want to give my previous, so I will just create another entry. So node star previous, and now I will create the constructor function, that is node. I will take my data, and I will do something sort of this. Take it as data 1. I will say data is now equals to data 1, that is assign this value to data, and your next becomes null and your previous becomes null. Right now they are pointing at previous. If you at null, if you want to change it, you can change it using the arrow notation. That is, you can access the node through arrow notation, node next or node previous or node data, any of the three, right? You can access these are pretty basic, and I'm sure that you know about it. I don't hope, I'm sure about it, right? There will be semicolons here. Okay, this is the case of implementing my doubly linked list. I hope there is no problem. This is not an topic that I should be wasting much time on. I should just jump to the linked list insertion. That is, I want to insert values in the doubly linked list, right? I want to insert values in the doubly linked list. How can I do that? So our second topic of the today's video is insertion, right? Insertion. So suppose the linked list given to me is 2, 6, 3, 4. This is my linked list. This is my doubly linked list. So as a part of doubly linked list, it will be my next, it will be my previous, right? Similarly, it will be my next, it will be my previous, it will be my next, it will be my previous, right? And this next is actually null, and this previous is actually null, right? So no problem in understanding that. So suppose I mark them as indexes 0, 1, 2. So this is, my head is at index number 1, my second node is at index number 2. Not index, I can say positions. This is position number 3, this is position number 4. And I get a query by the user to insert node after position equals to 2. After position equals to 2. Now this is my position number 2. So my user is actually representing that I want to insert a node here. Suppose the value I want to insert is 5. Suppose the value I want to insert is 5. Right? I want to insert a 5. So just repeat with me, what will be the linked list looking like if I insert the node at the given position. So my head will remain same, 2 pointing to null, right? 6 will be remaining same. Between 6 and 3, I will encounter node 5, then 3 and 4 will remain same. And if I draw the connection, it will be previous, it will be next, 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 and something sort of this in previous, right? Something sort of this in previous. And now we will be devising the same approach. In the case of linked list also, we did the same. We will be seeing the changes mentioned. Changes happened. Changes. What are the changes happened? So you can see head remains same. This was my head before. This will be my head now also, right? We will see the operation to change the head also just after this insertion, right? So changes are that our first thing is that the 6, that is positions next, is changed, right? Position node next is new node, right? Position node next is new node. Before it was 3, now it is 5. Similarly, position plus 1 node previous is new node. I hope you are able to realize it if you see this connection, right? Position plus 1, this was position plus 1 in the original linked list, so its previous is now my new node, right? And the two more changes are new node next, that is this connection is connecting to position plus 1, and new nodes previous is now position node, right? These are the 4 changes I can encounter if I want to insert something in middle. This one was for middle, right? This one was for middle, that is implementing anything here, right? Not at the end or not at the starting, right? So for middle, these are the operations. So I will do the same. So I know that I can only traverse forward or backward in the doubly linked list. So I will be standing here. I will be only given the reference to the head. I will be standing here. From here I will go here, or I will go here, which is at my position number 2. This is my position number 2, right? This is my position number 2. This is my position number 1. I have been given 2 as my argument. I have been given 2 as my argument. I have been provided with the head. What I will do? I will use a temp variable to traverse to this node, and after this node I will just do the operations. How will I do the operations? So you can see my temp is equals to head right now in the start of the initialization. My position is given to me. Suppose the position is 2. Suppose the position is 2. That is, I have in the original linked list, that is this linked list, this position is 2. I have to insert it something here. What I will do? So you can see temp is here. Temp is here. Now if I want to reach position 2, I will have to make one jump. I will have to make one jump. I have 2 in my hand. I have made one jump. That is 2 minus 1 jumps. 2 minus 1 jump. So I will say while position is not equals to 1, what do? Temp equals to temp next, and after that decrease your position. So position minus minus. Right? So after this loop, what will happen? My temp will come here. That is what I wanted. My temp come here. Now I will store this node as next. How will I access this node? This will be temps next. This will be temps next. So I will say node star next equals to temp next equals to temp next equals to temp next. Okay, so I have got my temp here, I have got my next here. Now the operations are simple. I will just make a new node, that is 5 here. I will make this, I will cut this connection and I will make it here. I will cut this connection, I will make it here. And now I will make 2 new connections, that is this one and that is this one, as mentioned in the 4 points listed below, that is these points, right? So what I will do, I will make a new node, let us say a equals to new node, right? And I will send the data I want to insert in the new node. After that, the for operation says that previous next is equals to new node, that is a, right? A's previous is equals to, not this is not this this is temp, right? Temp's next is a, A's previous is temp. 2 operations are done. Other 2 remaining are A's next is temp, A's next is not temp, it A's next is next, sorry, and next previous is a. These are the 4 operations that we have to mention to insert a node in the middle of the linked list, in middle of doubly linked list, shortly represented as DLL. What is the time complexity you took? So you actually took only this position, right? So O of position is your time complexity to traverse, right? All other operations were actually occurring in O of one time. This is your main time complexity, right? This is your main time complexity. But there are always edge cases in such problems. What are the edge cases? What if I insert a node here? That is, I am changing the head. Or what if I am changing the node here? So let us look at this, because this is very easy. So in the case I am inserting the node after 4. Suppose in the case of inserting the node after 4, that is, if I want to insert 5 here, right? I will be given the position of 4. I will be given the position of 4. My approach says that as you move temp here, just simply go to this node. The while loop will leave you here. So temp comes here, your next comes here. Now, what are the operations you have to do? You are changing temp next, T's next is changing, right? You can see new nodes, that is A's previous is changing, A's next is changing, right? The only operation that is not happening is null's previous is not getting changed. Next previous is not getting changed because next is equals to null. So in the given code, I will just add a line here. What I will do, I will say if my next is not equals to null, in that case, next previous is equals to temp. This is the only operation, and this node is now middle of doubly linked list plus end of doubly linked list. Now it's time for us to move towards the front insertion. That is, suppose a node 5 is here, connected something like this to 6, connected something like this to 7, connected something like this to 8, and this is null here and this is null here, and I want to insert a new node 4 here. I want to make it as head, right? Currently my head is 5. The operation is actually very simple. What I will be doing is, you can see 4's next is changing, 5 previous is changing. Just do that. Just make a new node of data, right? And now your A is next is your head. Your head's previous, your head's previous is equals to your new node, and your A's previous is null, which is already null, so I will not mention it. A's previous is equals to null. And now your head is also changed. So head is now A, and you can simply return your head. You can simply return your head, and as you can see, it is O of one time complexity. No extra operations are being taken care of. 1, 2, 3, 4, 5. O of 5 to be precise, which can be a constant time complexity. No problem in that. No problem in that. And now it is time for you to see the code. I have actually arranged a GFG practice problem link, so it will be easier for us to visualize if the code is running fine or not. So let us move down to there and just stay with me, okay? Alright guys, so here we are. So you can first see that the linked list, doubly linked list declaration is actually the same we taught. I teached you about it. I taught you. So next and previous are assigned, and next is equals to previous equals to null, and data is equals to x in the constructor function. So I hope that is not a problem for you. Moving on, there is a simple change here. It is saying that we have to assume zero based indexing. That is, head is at position 0, and I have to insert a node after the given position. That is, if the given position is to me 2, that is 0, 1, 2. 5 is given to me as the position. I have to insert after 5. That is, 6 will be inserted after 5. 6 will be inserted after 5. That is not a problem, right? That is not a problem. The operation says I have to reach 5. I have to reach 5. So if p is equals to 2 given to me, then you can see from head I have to make a jump from head to 4, 2 to 4, and 4 to 5. That is 2 jumps, and p is also 2, so I will make a jump of 2. So instead of going up till pos equals to 1, I will go until pos equals to 0. So I will make a node temp, give it as reference of head. Now what I will do, I will say while my pos is not equals to 0, what do I do? My temp is equals to temps next, because I'm traversing towards the final goal, and pos minus minus because I just use a jump, right? I just use a jump. Now my next is equals to temps next. After that, insertion happens. So node star a equals to new node with the data given to me. Now the operations, first operation was a's previous equals to temp. Temps next is equals to a. These are the two operations on the previous and the temp relation, right? Now a's next is equals to next, and now because it can be on the tail, so I will say if my next is not equals to null, that is, if my next is not equals to null, then only I can change next previous, that is equals to a, right? And I will simply return my head, right? The question here, they cannot get an head at position number 1 because it is said the minimum position can be 0, and 0 I will have to insert after 0, so head remains same, so I don't have to code for that. Let us try to compile and run it. Hope it will run fine. In the meantime, please try to subscribe to my channel and don't leave the video because there has been some error. I don't have to return anything, right? I don't have to return anything. Obviously, please don't leave the video because it is still left to see the deletion in the deletion of the node, right, from the doubly linked list. So please stay with me. We will just move there. It is taking a lot of time to compile and run. It has been running fine. Let us try to submit as well. Hope it will run fine too. It is running fine. Okay, so let us move towards the deletion of the linked list. So as you can see, I've already defined a linked list for you. These are my position based on the one based indexing. This is position number 1, position number 2, position number 3, position number 4, position number 5. No problem in understanding that. Suppose the question says that you have been provided with the position. Let's say your position is equals to 3, and you have to remove the node present at 3. You have to remove this 8. So what will happen? What will be the final linked list looking like? So 5, 6, 2, because 8 has been deleted, 1, right? Something like that would have happened, right? Something like that would have happened. Changes, let us see the changes. So 6 next, that is, suppose this is my POS, this will be my POS minus 1, POS plus 1. So you can see POS minus 1's next is equals to POS plus 1. This is one of the change. That is, this node is getting connected to this. That is this connection, right? Moving on, POS plus 1's previous is equals to POS minus 1. That is this. That is this one, right? Only these two are the changes you have to see, and this node is getting deleted, right? So if you are able to understand insertion, believe me, deletion is a cakewalk for you because it is really easy, right? What I have to do, I just have to delete a node. So if I manage to come to this node, if I manage to traverse to this node, what can I do? I will say that this node is my node. I will mention this node as my previous, and I will mention this node as my next, and I can just carry out these. That is previous next equals to next, and next previous equals to previous, right? Only this you have to do. So what I have to do, I have been given 3. Now the main thing you have to see is if I'm standing at head, and I want to reach third node, I have been given 3 as the input, so I can see 1 jump, 2 jump. So I will have to make 3 minus 1 jump. That is position is not equals to 1. Again, I will say my node is equals to head in the starting. Now while my position is not equals to 1, what will I do? I will say node equals to nodes dot next, and your position minus minus, because you just made a jump. After this while loop, you will get to the position where you want it to be. My previous will now be nodes previous, and similarly my next will now be nodes next, right? The two operations I want you to do is previous next is equals to next, because I'm deleting the node, and next previous is equals to previous, right? Because the node has to be deleted. Now if the node is not of any use to us, just delete your node. This line will delete your node into the memory and free the memory, right? And you can use the memory again for any other purposes, right? Now the case is for middle element, and we will see in the front and the tail again, right? So let us see to the tail. Tail is very important. Tail is very easy actually. So if my node is given to me 5, that means my node after the while loop will come here, right? My node is here, right? And if my node is here, my previous is here, and my null is here, right? And this is my next also, right? So you can see that the operation happening is previous next is getting changed, but null's previous will not get changed, right? Because null does not have a memory, so I cannot assign a previous to it, right? So that is the only thing you have to do. If my next is not equals to null, in that case only do it. This will be only done if my next if my next is not equals to null. This thing is to be done only for this, and now from middle it will become middle and tail. But in the case of the front, when I have to delete the head, it will be something different. What will be the difference? So suppose my linked list is 5, 2, 3. Let us take a small example only. This is null and this is null, right? Suppose I have to remove this. Position equals to 1. I have to remove position equals to 1. So I will make a separate case. I will say if my position equals to 1. In that case, I have to return delete head. I have to delete and return new head, right? Now this was my head. Position equals to 1. I have to delete it. What are the changes? The only change that will occur is I have to change 2's next. 2's previous will become null. That is the only operation you have to do. So I will say x equals to head next, right? Delete your head to free the memory, and now your new head is equals to x, and now x previous is equals to null. You don't forget to mention it, right? Don't forget to mention it. This will solve all your problems, and you can simply return head from here, right? So I hope deletion was also clear to you. See, I know that I'm not explaining you with proper time. I'm not giving many much more time, right? Because I don't want you to get bored, because this is actually very easy. As I already said, linked list is just about visualization. The more better you visualize, the more better you are at linked list, because believe me, linked list question are the easiest question that you can accommodate at any point of time, right? If the interviewer asks you a linked list question, or if an OA asks you a linked list question, please be happy, because you are definitely going to solve it, right? Because linked list just requires you to bring a pen and paper together and draw the arrows from here to here, right? Only this you have to do in the case of the linked list, and you will be able to see in the end of the playlist. By the end of the playlist, you will also realize that, right? It's now time for you to move to the coding section now. All right, guys. So here we are. So let us, without wasting time, let us write the code now. Okay. So what was our first operation? I will check if my position equals to 1. In that case, I will have to delete my head. So what will I do? I will say node star x equals to heads next. Now delete your head. Delete your head. Now x previous is equals to null, and head is equals to x, and you can simply return your head now. Return your head. This will be the case for front deletion, right? Now moving towards the middle and tail deletion. So what I will do, as I discussed, I will have to traverse until my position equals to 1. So I will create a node for deletion and I will assign it as head, and now make this node traverse up till the node which has to be deleted. So while my POS is is not equals to 1, what will I do? I will say node equals to nodes next and POS minus minus, right? Moving forward, my node star previous is equals to my nodes previous, no problem in that, and node star next is equals to nodes next. The operation I have to do is previous next is equals to next, because I'm deleting it. And now second operation, the only second operation was that if my next is not equals to null, that is I'm not standing at the tail, I don't have to delete the tail node. In that case, next previous is equals to previous. And after both of these operations, you can safely delete your node, right? And you can safely return your head, right? Let us try to compile and run it. Hope it will run fine. In the meantime, please do consider subscribing to my channel because it gives me a lot of motivation. There has been some typing mistake. It will be next here. Let us try to compile and run it now. Hope it will work fine. It is taking a lot of time right now. As you can see, it is running fine. Let us try to submit it as well. As you can see, it is running absolutely fine, and thank you for watching the video. I appreciate that you are still here and you didn't get bored. Moving towards the next lecture, we will be discussing furthermore questions about the Doubly linked list, and we will be introducing to the new concept of circular linked list as well. And believe me, this playlist is a like one shot for mastering linked list, right? Okay. Thank you. Have a nice day.